Notation and evaluating functions. So I have a little situation. Let's talk about what this function notation is first, and then we can talk about how to evaluate it. So the equation y equals 9 minus 4x represents a function, and the equation y equals 2x represents another function. So what function notation is used for is we use function notation to represent these two functions so that we can tell the difference between the two of them. So for example, if I asked you, what is y when x is equal to a 6? Well, these are both y's. So how do you know which one to substitute it into? You can't just take a guess. I want a specific answer, and these are going to give me two different values of y for the same x value. So we need a way so that I can clearly tell if you mean the 9 function or if you mean the 2 function. That's what function notation is for. So what we do in function notation is we use letters to name them. And here's how you would name them. We basically replace y with f parentheses x. So what we could do for this first function is we could change out this y for, let's say, so we could change this. We could change that into f parentheses x equals 9 minus 4x. And then I could change, let's say, this function. I could replace this guy's y. I could replace that with another letter. So let's say g parentheses x equals 2x plus 4. So now I can clearly tell if I ask you for the f function, we're talking about the purple one. If I ask you for the g function, we're talking about the blue one. So this is a very easy way for us to tell the difference between lots of functions when we have more than one or two being used at a time. Now, what does that f parentheses x thing mean? So first, this f parentheses x, that's not how it's read. We read this as f of x. So how I remember is when I write a parenthesis, I say the word of. So it's f of x, and then we close the parenthesis. Okay, now in math, here's what this means. This means the output value, that's what that f of x is, of the function f, that's the name, for the input value of x. So whatever's inside here, that's your input. It can be an x, it can be a z, it can be an r, it can be a 2. That's how you know what the input is. So basically the f is the name and x is the input. And here's our little example. We have f of x equals 9 minus 4x. Let's do some labeling. So first, the f of x is read. It's read as f of x. And this is equivalent. This is equivalent to y. It's just a different way to say it. So f of x is actually y, which means this is an output. This is that range value we talked about. F of x is range, f of x is y's. Now, let's get more specific here. The f piece is simply the name. F is the name. F is the name of the function. And you can call it whatever you want. We could call them G, Q, R's, K's, any letter of the alphabet is perfectly fine. We usually like to stick to F, G's, and H's. That's the most common 3 that you see. We like F for, well, function. Okay. And then finally, this thing on the inside of the parentheses, in this case, it's an X. This is the input. Now, that can change. It's the input variable or number. You can put numbers in there. I could ask you for f of 2, which we're going to do here in just a minute. And if you notice, this guy here and this guy here have to match. So whatever is here also is there. That's how you know what the input value is in case there's more than one variable. Okay, so let's talk about evaluating this stuff. So now that we kind of learned what function notation is, let's talk about evaluating. So here's example 1. For example 1, we are given that f of x is equal to 7x minus 1, and we want to find f of negative 2. So remember, that's how you read these. When you write the parenthesis, you put an of. So we say f of negative 2. So now here's what to do with this. Well, since the -2 is inside the parentheses, what that tells me is that tells us that x is equal to -2 because x used to be in there, see? X used to be in there and now it's a -2. So we've replaced x with a -2, so that means those are equal. So what we're going to do is we're going to replace all the other x's with a -2. That means this one here. So the proper notation is we say f of -2 is equal to, because remember, this is what we're trying to find. So f of -2 equals, and then we're going to plug in a -2 where the x is on the right side. So 7 times x is really a -2 minus 1. And then all we have to do is simplify this piece, because this is what we're looking for. Simplify the right. So we have f of -2, that's just going to kind of follow us down, equals 7 times -2 makes -14 minus 1. F of -2 equals -14 minus 1 makes -15. And this is your solution. This is your answer. You found what f of -2 is. F of -2 is this -15. Now, remember how I said f of x is the same as y? What you've really just found is that y is equal to -15. The f of -2 is just the more mathematical way to write the answer. So here's what this actually says. This says the function value, and when I say function value, we mean y value, at x equals -2 is -15. That's what that means. The function value at -2 is -15. So our solution to f of -2 is -15. Let's try another one. So example 2. Let's try another one together. So we're going to be given g of x equals 5 times 3 minus x all squared. So now I got exponents and variables going on. And I want to find g of 5. Also, another thing, take a look. This and this must match. This means we're using the same function. If I have an f here and a g here, I can't evaluate that because they're two different functions. Pay attention to what the names of the functions are. So again, 5 is inside the parentheses, so that tells us that x is equal to 5. And so we're going to replace x here with a 5. Now again, we're looking for g of 5, so we're going to say g of 5 equals, because that's what we're looking for. Let me change colors here. So g of 5 equals 5 parentheses, 3 minus, and then when you replace x, make sure you have a parenthesis around it so we don't lose negatives just in case we have negatives. And this is what we're going to have to simplify. Simplify using your order of operations, guys. Order of operations was parentheses, exponents, multiply, then divide, add, and subtract together. So let's start. So g of 5 equals 5 on the outside. I got to get all this parentheses stuff done. So I don't have anything in this parenthesis, so this is just 3 minus 5 squared. Now I need the other set of parentheses. So 3 minus 5 on the inside makes -2. Now here's the trick. Exponents have to come first. So -2 squared makes a +4. Exponents have to come before you multiply. And now that I've gotten rid of the exponents, I can multiply 5 times 4, which makes 20. So the value of g of 5 is equal to 20. Again, the function value at x equals 5 is 20. And let's do one last one before we try some on your own. So example 3. Given, and they'll give you the function, h of x equals 2x squared minus 5x plus 1. Find h of -3. So again, we've got -3 in here. That means x is equal to -3. All x's are equal to -3. So we're going to replace this x and this one with a -3. So we have h of -3 equals, because we're looking for 2 parentheses, x is really negative 3 squared minus 5 times x again, which is really another negative 3. All the x's get replaced. And then plus 1. And then again, all we're doing is simplifying, so use your order of operations. So parentheses have to come first, but inside the parentheses is simply negative 3's, which I can't make any smaller. Then the exponents, so negative 3 squared has to come before you multiply. So negative 3 squared is a positive 9. A negative 3 times a negative 3 makes a positive 9. Now over here, there is no exponent, so I can go ahead and multiply those in. Negative 5 times negative 3 is a positive 15, and drop the plus 1. And then we continue. The next thing I can simplify is 2 times 9, which makes 18, plus 15 plus 1. H of negative 3 equals a 34. 18 plus 15 plus 1 is equal to 34. So the value at h of negative 3 is a 34. So now, what happens if I don't give you x? Let's look at example 4 and 5. So example 4, what happens if I don't give you x? You're given f of x equals 5x minus 1. What is x if f of x is equal to 9? So make sure you're paying attention to the placement of the numbers. The previous examples, we had the 9 inside the parentheses, but it's still an x. My 9 is outside now. So I'm not giving you x anymore, and we can also tell that because it asks me, well, what is x? And if I'm asking you, I don't know what it is. So this is actually the output value. This is actually meaning y is 9. So I'm giving you the end. I want to know what did I put in here in order to get me a 9. This is the ending value. So what we have is, this is the actual function, f of x equals 5x minus 1. Well, if f of x is equal to 9, then that means I can replace this guy here with a 9. So this f of x gets replaced with 9 because those are equivalent to each other. The same way that I can replace x's with numbers, I can also replace the f of x, because remember f of x is just a y. I can also replace this guy with a 9. And then we still have on the right 5x minus 1, because I don't see another f of x anywhere. I just see a plain old x. Well, now if I'm trying to figure out what x is, I'm going to solve for x. So I'm going to add the 1 to both sides. 9 plus 1 makes 10, equals 5x, and then divide by 5. So we get x is equal to 2. So basically, the x value of 2 is what produced a y value of 9. I gave you the ending. I wanted to know, what did you actually plug in? Let's do one more of these kinds together, and then you get to try some on your own. So for example 5, you're given h of x equals negative x plus 2. Find x if h of x is equal to 6. So again, I'm giving you the ending value. H of x equals 6 is telling me that y is a 6. That's the end. I want to know, what did I put in for x? So the original function, I'm going to write that down first. Here's the original function. H of x equals negative x plus 2. And I can replace this h of x here with a 6. So this entire h of x goes away, and I get a 6 in its place, because those are equivalent to each other. They're equal. So 6 is equal to negative x plus 2. Then to find x, we simply solve for x. We're going to subtract 2 from both sides. So we get 4 equals negative x. Divide out the negative 1, and we get x is equal to negative 4. So we substituted a negative 4 to get a y value of 6. So now I want you to try these. We have 4 functions. At the top, we have f of x, g of x, h of x, and j of x. So we've got letter A, letter B, letter C, letter D. Pay attention to the names and make sure you're using the correct function. So for letter A, since it's g of 10, you would be using the g function. So you're going to use all 4 of these functions to try to find these values that are asked. Pause the video, see if you can find their solutions, and when you're ready, unpause to find the answers. Here are your solutions for A, B, C, and D. So let's move on to some graphs and tables. So I have 3 graphs here, and I have 2 graphs in a table. So I have F graph, I have a G graph, and I have an H graph. So make sure you're paying attention to which one is which. So for example 6, we're going to find a few values. So for example 6, I want us to find G of 13. Okay, well, if I'm giving graphs and tables, there's really no math involved. It's just kind of looking and trying to see what value you have and what you need to find. So 13 is inside, so that means x is equal to 13. But there's 3 options here. That's where this comes in. So we're actually using function G. Match up your names. So here's the G. So this is G, this is H, this is F. Okay, so I have x equals 13. I want to know what y is. That's basically what this means. So what we're going to do is on the x side of my G, I'm going to find 13, and the matching y value is 18. So 13 is what they gave me, and 18 is my solution. So G of 13 equals 18. And that's it. Read your tables, read your graphs. And so now let's try example 7. Let's do another one. Example 7. So for example 7, we're going to find f of negative 5. So again, pay attention to what you're using. We're using f. So that's our graph f. And negative 5 is on the inside, so that means x is equal to negative 5. Find the y. You always have 2 pieces, an x and a y, an input and an output. Since it's on the inside, you're given the input, which is x. So find where x is negative 5, so that's right here. But it actually hits my graph here. Find the actual point that's sitting on the function, the curve, the line, whatever it is. And so they gave me this value. Well, then the unknown has to be this guy. So f of negative 5 is equal to 2. Gave you the x, find the y. So let's do example 8. So for example 8, find h of negative 3. So again, the name is we're using graph h. Then the negative 3 is on the inside of the parentheses, so that means they're giving me x and they're asking me what is the y value. Well, here's the h, find where it's negative 3, so here's the x value of negative 3, but this is where the actual function is. Don't sit on the axis. I want to know where the point or where it is on the line. So they gave me this value. That's how I found my location. Well, I need the other half, and this is also at a 2. So h of negative 3 is equal to 2. They gave me x, find the matching y value. Okay, let's do a few more. So example 9. Find all values for which f of x is equal to 1. Now, pay attention. Make sure you're really focusing. This is the f graph again, graph f, but 1 is on the outside, so this is actually y equals 1. Remember that f of x is just really fancy for y. So this is saying that y is equal to 1, and I'm trying to find my x. So let's go up to my graph that has the f. So here's the graph that has f. So they gave me the y value this time, so a y value of 1. And I'm going to move across to my graph. So here's where they gave me. So I hit my graph here, here, and here. There's multiple points that have a y value of 1, and that's okay. So now I says, well, I want all the values. So one of the values is negative 4, another value is negative 6, and the last value would be negative 8 that doesn't have a label. So there are actually 3 x values. X equals negative 4, x equals negative 6, and x equals negative 8. There were 3 x values that gave me a y value of a 1 for that graph. So there can be multiple answers, depending on, especially even depending on if it's a function or not. So find h of, oopsie, parentheses in the wrong spot. Find h of negative 2. Okay, so again, make sure you're paying attention. H graph. I want my h function. Make sure you look at the name and the placement of the number. -2 is on the inside, so that means x is equal to -2. And it's asking me, what is the y? So let's come up here to the h. So here's where x is equal to -2. And if I scan up, well, I didn't hit a point. Let's scan down. And I still didn't hit a point. So there isn't a point that has an x value of -2 for h. It doesn't exist. There isn't a point there. And that's exactly what your answer is. So there are no points. There are no points on x equals -2. So what that means is, that means h of -2 is, we call it undefined. Because there is not a point, we call that undefined. There we go. Because there's not a point on that x, there is no y for that specific x value. So it's not defined. We say it's undefined. And then we have our last one, x example 11. So what value is x when g of x equals 25? So again, see what it's asking you. G is the function you're using, so function g, that's the name. And it says g of x is equal to 25. Well, that means y is 25. G of x is just really fancy for y. And it's asking you, what is x? So you don't know the x value. Okay, so we're going to go use our g graph. Well, this is actually a table. And it gave us the y. So we're going to start on this column this time. Find the 25, and it's x that gave that 25 is a 20. So our x value, so g of 25, oopsie. So our x value is x equals 20. And x value of 20 gave us a y value of 25.